relationship. This one does happen to be a function, but they're not always functions. We'll use this to figure out our y values, okay? So, let's see, raise your hand. Tell me what I should do to figure out the first y value of x is 0. Ash.
You will substitute 0 in for the x there.
Thank you. So I would have y equals 2 parentheses 0 because the x is the 0 is substituted in for the x. Thank you for not saying plug it in. That's a pet peeve of mine because you're not plugging anything in. Right? No plug and chug either. So we are substituting the 0 for the x, and of course this needs to multiply. So what's the corresponding y value we would get, Tiny? 0. So for x is 1, I'm going to go through this quickly because we really want to get to this part. So if x is 1, we would have y equals 2 times 1. So y would be, Tim? 2. 2. So if x is 2, we would have y equals 2 times 2. So x would be, Quentin?
Oh my God, 4.
You weren't listening, were you?
No, I was. I mean, I already did the table. I'm just going, I don't know how I messed up almost.
So I have y equals 2 times, this time x is 3. So y is equal to, Amanda, 6. Oops, I don't put that here. It goes here. So I have y equals 2 times 4. So y is equal to, Ash, this actually?
Yes. 8.
8. And then the last value I gave you, y equals 2 times 5. So my y value is, Catherine? 10. So this is just a review. I know all of you are thinking, we all know that. Go on, old lady, and get to what we need to do. So now we need to graph these. This generates a set of ordered pairs that we just need to graph. So if x is 0 and y is 0, where is that point? At the origin. Right here. So if x is 1 and y is 2. From the origin, tell me how to move to get to the x is 1, y is 2 point. Pam.
I'm sorry, I was wiping my face. What'd you say?
I'm sorry. From the origin, because we've already graphed the ordered pairs 0, 0.
We go to the right one space on the x-axis and then 2 up on the y-axis.
Okay, so that would be approximately here.
Yes.
I just have a question about your graph, the y-axis. If you'll be able to fit off of that.
Good question. Am I going to be able to fit all those ordered pairs on the y-axis as I have drawn it?
Top right, there was 25.
That's a tiny 5. So no? Ashley said no, Brandon. What do you think?
I said no also. You need to extend your y-axis, or you could change up your intervals also.
And I don't want to do that because that's a
Okay.
lot of erasing. So how would I extend my y-axis?
With a meter stick.
Brandon, tell me what to do here.
I will touch chalk.
You would take your y-axis and create your intervals of 1 up until 10.
Okay? So I'm short. I'm probably not going to get there. That's as far as I can go.
Okay.
Okay? So this is going to be 6. This is going to be 7. I might can get to 8. Okay? It's good enough for y'all? Okay. Are you happy now, Quentin? All right. Okay. So we've graphed this ordered pair. We've graphed this ordered pair. We're down to 2, 4. So you're going to think I'm Tanya.
Mm-hmm.
Tell me how to graph the ordered pair 2, 4.
I'm going to bunny hop to the right 2.
From where?
From the, whoa, the point of origin.
Okay. Pam, did you tell her?
No, I didn't.
She just looked at me and went frazzled.
From the origin.
And then I'm going to go up 4.
Okay, you've already told me 2 to the right.
Yep, 4 up.
4 up. So I'm approximately here, right?
Mm-hmm.
Okay. So the next point then, just one more person, and then we're going to talk about the slopes if this is forming. So I keep looking at the observers here, and I don't want to call on y'all. I can call on Denise. So.
Okay, you start at the point of origin,
Mhm.
and you bunny hop over to the 3. And then you take giant leaps out to the
You
6.
go to the right
Okay,
first.
so that's approximately
I did the thing, okay,
Here.
I didn't.
one more point, because that's all I can get on my graph. Who did I not call on? All right.
Hi.
Hi.
And we're doing the fourth correct, so I'm going to go from the point of origin 4 to the right.
Okay.
Then I'm going to go up all the way to 8 on the Y.
Okay. So we're approximately here.
There's already a dot there.
There was already a dot. Okay, and this forms some kind of graph. If I were really good at drawing this up here, it would be linear. It would be linear. So do I connect the dots or not? I've heard a no, I've heard a yes. Sam?
It depends on whether your data is continuous or discrete.
Okay, I don't know what continuous means. What does it mean?
There are points in between each number.
Okay, so there are values in between this point and this point
Yes.
that would count, that would be appropriate for that. That's continuous. And discrete? The opposite.
Yes, and
Okay.
we're only one data point for, there is no parts.
So if we're using my pattern blocks or Cuisenaire blocks that I won't let you break apart, that's gonna be what kind of data? That's discrete. Remember all this vocabulary we did last time? That's discrete. But today we dealt with time and distance. So is time discrete or continuous?
Continue.
It's continuous. And distance? It's also continuous. So we have continuous data. So I can connect these, that linear function, right? This is linear. If y'all don't believe me, then something's wrong. What'd you have for breakfast? So in your activity this morning, you were finding, what were you finding? What did you call it? Velocity. You were finding velocity. And what's that formula for velocity? I never quite wrote it down on his paper.
Change in distance over change in time.
Distance over time, thank you. Distance over time. So, and she said change in, so I guess I could do that. Change in distance over change in time. So what is the change in distance from this point to this point? I'm sorry, from this point to this point, what's the vertical change?
2 hamsters.
2.
2 hamsters.
2? All right, now don't get me all confused, okay? I've been up a long time. And what's the change in time from this point to this point? 1. And I'm not putting units up here, okay, because that's not my focus right now, all right? So this is also called, and this is going to be consistent for each one, and in mathematics we call that what? Back up that question. What do we call that in mathematics?
What is that?
Thank you. What do we call this value in mathematics if it's true for every distance between every point?
It's proportional.
It is proportional.
It's
Multiplicative.
also ratio.
It is multiplicative.
It can also be a ratio.
Like constant.
The ratio.
Change.
And it can be a unit rate.
Unit rate. Brandon said constant.
Rate of change.
Constant rate of change. Okay. What if I use this point here, the origin, and this point? What would be my values here?
4 and 0.
4, 2.
From here to here, what is my change in the x value?
2.
Where did that go? What is my change in the y value?
4.
4. So is this equivalent, this ratio equivalent to this ratio?
Yes.
So it's constant because it is linear? Yes, ma'am?
We can call it a rule, right?
We could call it a rule. We call it
Let's
a
call it
rule.
one more thing.
Why does it have so many names?
Because for different situations, we use it for different reasons.
Yes.
And because you're adults and you know what to do. There's one more name for this that I'm looking for here.
No, I think it's
Why?
all of
Oh,
us.
wait, that's the slope.
So,
Could be called a slope. Okay? Could be, yes, could be the hypotenuse, yes ma'am.
I think her frustration is we have so many English language learners, if that's their second
Yeah.
language, and they're like, oh, I thought you said that's a ratio. Well, it is. Well, you said it's a proportion. Well, no, well, it's that too, you know?
Well, if you have these two together, it's proportional.
Uh-huh.
Yeah, you have to have two to be a proportion. So, yeah, you're right, English language learners would be confused, but they also wouldn't have said all of this. Because my lesson leading up to this would have been talking about slope. So they would have gone straight to the word slope. They would. And if not, then I would introduce the word slope. And that's, what's the definition of slope? I don't want a mathematical definition, I just want a layman's definition of slope. Brandon?
I'm thinking of steepness of a hill.
Okay, steepness of a hill. So if you're driving along in California, sometimes it'll give you a number and it'll say slow way down because it's really steep. We'll have a picture of a steep hill on the sign. Okay? We also have those in East Texas. All right, so that is slope. So tell me exactly what this is telling me from a graph. At graph. And remember, this is all review. What is the 4 representing? Thank you, Ashley, for frowning. I didn't ask a good question. You were like, what are you talking about? What does the 4 represent in this equation?
the change in Y.
The change in Y. That is the change in Y. What does the X, the 2 represent in this equation? Change in X. So where do I start to find this change? How did I get 4 there? I started at the origin and I went to this point. Could I have started here and gone here?
Yes.
Okay. So what is my change in, I'm gonna write that point down. What's my change in Y from here to here?
From 2 to 6.
Okay, Brandon's holding up 4 fingers. Do you agree? I can't call on you. You agree, Ashley? Either one. What'd you say, Brandon?
I said it was 4,
4?
man.
So what's my change in X from this point to this point? Can you see it? 2, from 1 to 3, 2. So does it matter which point you're starting on, if it's linear? Does the slope change depending on where you start, where you end? It does not, it's constant rate of change. So now let's look at one of your sheets, okay? See what we're, if that has any relation at all. Can I just borrow yours? That's okay, we like messy. So, okay, we're not graphing yet. So we're looking at this table here, okay? Looking at that table, can I zoom in a bit? Spin it. Okay, what was her first ordered pair, Amanda? Where'd you do this? What was her first ordered pair, Amanda? Here, let me put my little fingers on it for you.
Which table are you looking at?
Yeah, we
The one on the
use
left.
us to.
I'm looking
Two
at
books in the front.
this table.
So is it 3? No.
Very first ordered pair in the table.
Is it the point, no, 5, 10?
Let's back up a minute. So what is the X value representing?
Time.
Time, because she's labeled it seconds. So her X value is representing time. What is her Y value representing?
Distance.
The distance. So the first time was zero, so it had not moved at all, right?
Correct.
Started at zero. So the first order pair is 0, 0. The second time is 1/2 of a second, correct?
Yes.
Okay, so her distance was 3, and I believe you measured in centimeters. Okay, so now she's gonna finish explaining this table, or did I explain it well enough for us to go on?
That's fine. The two right columns, we did 2 different takes or trials. So the first time we did it, we got the first column. We did it a second time with a different marker, and then we got our second data points.
Yeah, so we're really only looking at that for right now, okay? Just for these purposes. So for her second data point, the time was 1/2 second, and the distance was 3 centimeters. The third data point, the time was 1 second, and the distance was 8 1/2 centimeters. The fourth data point, the time was 1 1/2 second, and the distance is that 16? 16 centimeters. So looking at the time, it's going up at a constant rate of speed, right? Constant. Looking at the distance, is it going up at a constant rate of speed?
No.
Said that wrong. Constant rate of change. No, the change from 0 to 3 is 3. The change from 3 to 8 1/2 is 5 1/2. The change from 8 1/2 to 16 is 7 1/2. So this is not a constant rate of change right here. So at the first level. So that's not going to be a linear relationship, or so it appears. Of course, we would have to have several trials to make sure, right? But so it appears it's not, okay? So, in this, that's their second take, which we're not gonna look at. How far do you want me to go, Ms. Laura, before you hop in? Have I gone far enough?
Yeah.
Okay, so she is now gonna take this over to your graphing.
Okay, I'm using this data, and I'll give you your paperback because I've copied it down.
Ashley,
And so I copied down that first trial you did here. Can y'all read that, okay? Yes. Okay, so here's the time, 0.5, 1.0, et cetera, et cetera. And then the distance is in this second column. So now our job is going to be to graph it. And instead of using the little bitty graphs on your handout, we have some big pieces of graph paper that I think it would be nicer if we used that, assuming I can get into it.
You're graphing.
So each person probably grab 3 or 4 sheets of graph paper, please.
Wait, you said each person, not each group?
But it's the whole people.
No, that's fine, I would prefer to have
Everyone needs 3.
Okay, here's one that's 3.
She's so smart here, especially as far as trying
Yeah.
to.
There are people in cars.
One more time.
Okay, so
Did you get some?
Okay.
Anybody else?
I'll put it right here so I can steal it.
okay, guys. You may want to use one piece of graph paper as your straight edge so you can make your axes.
I think Ruby's getting us rulers.
Oh, rubies. Oh,
Yeah,
Brenda.
she's getting us rulers, thank you.
I got them.
Oh,
Oh, there's some really good stuff. All right, so Dr. Browning went over how to graph. So you know how to form your axes, you know what to do. So let's go ahead, you figure out, your data is gonna be different than mine, except the Ashley's. If you want to.
Tuesdays we real pink.
You do, that's sweet.
Why?
So, we're gonna create first a graph of this data right here, a distance versus time graph, just like Dr. Browning did for this data on the board. So on mine.
So you want us to do that one?
No, you can do yours, yeah. On my data, on Ashley's data, my grid, I just grabbed the paper that was on top, so my graph paper looks a little bit different than what you guys have. So I used mine in the portrait orientation. Time on the bottom, and I'm just graphing through 4.5 seconds, 4.5 seconds. And then my scale on the y-axis went up to 120 centimeters. So, as y'all go ahead and graph, I'm gonna plot my data too.
Each two is.
The y-axis, I'm putting the numbers, because we would go up to 100.
What's that maximum distance? 50 bases?
If you skip every other box. Mine, I have, my y-axis is going to be a little bit shorter than yours, so you may
Right.
be able to do more. So I'm going to skip every 2.
I mean, we could do it in meters, but.
No, I think that would be a great place to do it.
Hopefully that's not going to
we use it for.
Where do you run?
I just realized.
See, we did our job. What did you do? Because, we didn't pay attention to this part. We didn't do points. Okay, so what you're telling me is that between the beginning point and the first one, there's 4 seconds.
Correct. That's the point. Because then, okay, now that I'm looking at it in common sense wise, would say 21 seconds to go down that slope was wrong. Over here, 24 seconds to go down that slope was wrong. Okay, see, so we didn't do it right. Okay. And we did it wrong both times.
Okay.
Okay.
Well, then do you wanna?
And so,
data?
and that's what I'm trying to do, I'm trying to do that data, because this data, the first time and the second time is wrong. So now we're doing that one. And I'm like, this is should I have?
So I know when I need to zoom in on that.
Velocity and
No, we haven't done any velocity columns.
Okay, so, all right, so here's the second one.
If I were you, why don't you write the data down first, so you're not having to shoot try. Yeah. And we're gonna expand on this, so, yeah.
I am impressed with my.
Because we did not pay attention to the buckets, and we just supposed to just go forward. So you know how I was saying that, when we did because mine was 2.5 books. When we did the 2.5 books, that's 7 points, was like at the very beginning. See, and so then we said, no, we're gonna have to get to see the whole thing.
Well, but, you know, like we have points that we have here.
But to see our consistency in our data, it went down to like, because we had to use a lot of data points to see the consistency in that. And I'm talking.
And they didn't feel good there.
Like hers on the 3 book, it made a big difference from 2 books to 3 books. And so, I was like, okay.
So it's, you have to figure out, is it additive or negative?
This is my data.
It's a lot like mine.
We're gonna do that Monday. And I was to cut it down, I think I was gonna get to it Friday. Look at it, so, oh no, we read that in kindergarten, so really, because I'm gonna read that in math. Old couple of the magic pot.
On this side here, we're gonna have 5.5 curve also.
Second and a half. Except for we just did seconds instead of half.
So just change these points are correct. So change these to
So, this is what we originally
Why?
Mine is actually correct.
it's busy.
Yeah.
You gotta get some.
Well, I'm sure there's Yeah, I understand she's
No, I see what
Right.
I was just looking at I was like, oh, look. Oh, it's a question.
Because we were timing every dot. It said it was going to be
She drew on the tiles on the board.
every second, right?
And drew a 10 grade. It's strange. They say permanent clay. It doesn't go. Drafting data.
So they said, so here's my first point.
And the translation.
So my first point,
But she did the tiles and the next and y-axis on tiles. You know, somebody would call out an ordered pair, like, first person to out to got the spot.
And we lay on our team, data, then this is why we go.
I did, and then we were doing just fine by the watching. The number line, that's what I did, the number line, you just masking tape. I was doing this fraction problem, and then they had to be able to create the number line with the right parts, you know, between 1 and 2 and 3, and they had to create the right, you know, each parts in between before they would do the one. Called out the numbers. I tweeted. Well, and it's one of those things though, am I making sense? I was hesitant, she scared to do Twitter.
Because that's what you're
Well,
going
first of all, you have an emergency
to.
card, then she's like, but that's not silly. We said no for our daughter, you know, and she's in such a great space that they have rolled out. But, going back, by tweeting some things that we're doing.
Oh, yeah.
okay, so
If this is ready, started following after doing activities on the class.
what would I put for my?
I thought about that. I was like, we should set up a teacher exchange program.
Okay,
A lot of, so I'd like started with that.
okay, y'all, you need to come back together, please. And, lost my whole train of thought when the food appeared. Laura has a graph that she has drawn up here. So we have been talking about this function up here. And the function that I wrote produced a linear graph. Okay? So now I want you to look at this graph. Does it appear to be linear?
No.
So raise your hand if you think it appears to be linear. So raise your hand if you think it does not appear to be linear. Raise your hand if you're not quite sure.
It's kind of iffy.
It is kind of iffy, and that is because we don't have a whole lot of data points up there. We need more data points to do that. If you look at in a small section of it, it can look linear when it's actually not. So let's figure out if this is linear or not. If it's not linear, what's going to happen here? Remember, this was the change in y over change in x. Change in y over change in x. And it was constant each time. So if it's not linear, what's going to happen to the changes here?
It's gonna fluctuate.
They're not going to be constant, all right? So looking at her graph, I don't know if you can see this, but the first, I'm going to put the numbers on here. The first ordered pair is 0, 0. The origin. Can you see that? I'll cover Ashley's for a minute. I'm going to zoom in for a little. All right. So that didn't work, did it? Okay, there we go. First ordered pair is 0, 0. I'm going to make a table right here, okay? First ordered pair, 0, 0. What is her second ordered pair right here? Three. What's the x value?
0.5.
0.5.
What was it?
5 tenths.
5 tenths.
5 tenths.
What's the y value?
Listed, 3.
3 about, we're estimating. Okay, so the second point, right here, what's her x value?
1.
What's her y value?
9, 8.
9.
9-ish? Okay. Third point, x value.
1 and 5.
1 and 5 tenths.
1 and 5 tenths, 1.5. Y value.
16.
26.
No, 16.
16. So looking at our y values, are they increasing at a constant rate of change?
No.
No. The rate of change here is 3, correct? The rate of change here is 6, correct? The rate of change here is 7. Not increasing at that constant rate of change. Okay? So will this be a linear graph?
No.
Okay, good. Because now we're going to talk about some of y'all's graphs. All right? Do you have any particular one? Okay. So before I get to Tim's, we will look at someone else's. Do I still have Ashley's?
Yes, that's it.
This is Ashley's? Okay, so what do you want me to do with this? Let's look at this, okay? The first 4 points up there are the ones that were on this other graph that Miss Laura had done for me. So going on down, from the change from here to here is 3. And we said this one was from 3 to 8.5. Thank you. 5 and 5 tenths, 5.5. Okay. Here to here, 7.5. Here to here, 10 and 2 tenths. So we've established it's not going to be linear, it's going to be some type of curve. Okay? If we kept going, these are called finite differences, by the way. These are called finite differences over here. If we kept going, what do you think is going to happen with those finite differences? Will they, Brandon, what do you think?
They should get greater distance apart.
Okay, they'll get greater distance apart. Meaning, if I went to the next one from 26 and 2 tenths to 38, that finite differences should be larger than 10 and 2 tenths. Okay, so looking at hers now, well, let's go back and look at the graph that Laura has. So, can you explain to me, that's not a good question because it's yes or no. So, I'm going to ask someone to explain to me what that really means, what that really does to a graph when those finite differences are not constant, instead they're increasing in quantity as you continue in your table or on your graph. So think about that for a minute. Okay, now you can talk to your partner about it.
Partner delivers.
As your
As long as
Y
it's-
value.
as
So
long
what
as
we were
it's-
discussing just a minute ago is if that were the
Slope is
case,
going to
then
push.
would we be able to have, you know how we have like so Y equals to,
So if you compare the Y values
would
from
we
the
be able
last
to
year,
have that
versus the
because,
first.
Well,
right,
but
this
we're
is
going
fluctuation,
to-
it's not going to the consummation.
Rate of change, yeah, rate of change. Well, no, because we're just looking at the
Right.
X's and Y's, it's just that the time doesn't change, the rate doesn't change. So it's the distance between our last two years.
Yeah, I thought so too, and I was like,
Last year causes
Then I was perplexed.
I'm sure there is. I'm sure it's over here.
What happens, what is, now, I realize that this is what is this
Just like as soon as the end.
So yes, there would have to be
So
some.
this distance, and so.
But in the beginning, you were looking at it saying
Second, and third,
they're probably up.
was about 5.5, so instead of 4 and 4.
I don't know if that's even.
This order pair would have to go down and then
And that's
compare.
what it's stuck
And then if you just keep decreasing,
in.
I mean, eventually you can't go lower.
Okay, you've got about 5 seconds to wrap that up. And since we're using Ashley's data, Ashley and Ashley's data, I'm gonna ask, y'all with me? Okay, since we're using Ashley and Ashley's data, and this Ashley teaches high school, I'm gonna ask Ashley and Ashley to come up here, and this Ashley is going to explain to the class their conversation that they just had, okay? Come on up here, we wanna see your graph.
Come on down.
All my extra.
We go into
So, we were talking about the rate of change and where the distance increases, but the time doesn't increase, and that kind of is
The
what.
change in the time, because the
Right.
time is increasing, but the change in the
Okay.
periods of the time.
Right, the change in, the rate of change of time will remain constant. But the rate of change in distance actually increased over time.
Okay? Why?
It picked up speed as it went, maybe. We were also sometimes having issues with our, machine.
Okay, so with the
It's
issues,
staying
that-
on course,
okay,
which
so you said
affected.
issues in your machine. So does that mean everybody would have the same issues, so everybody's graph would look like that?
We had the same.
Not necessarily.
Not necessarily.
We had the same issue. Yeah. I think you had.
Right,
yours.
we borrowed
Yeah.
theirs, but we also used it on a different surface, a different table. Or we used to elevate our ramps with maybe differently. So, we were talking about how this would be a great conversation for, your outliers. Instead it's like, oh, well, you screwed up. No, you don't screw up. Just something happens you didn't expect.
So Ashley, the other Ashley, you wanna add something to this? No? Okay. Can we keep your graph up here? Tell me what your distance was measured in. Your distance was measured in centimeters. How many of you measured in centimeters? Almost all of you. Tim, what did you measure in?
Our first graph is measured, our first two graphs are in centimeters,
Okay,
but when we did our third graph, we converted them to meters.
Okay, so would you bring that one up here, and Ashley, if you want to sit down, leave that here.
Okay.
You should have
Okay,
said
we want to compare your graphs. We want to see who's right.
The first table is measured in centimeters.
Okay, so looking at their two graphs,
I love graphs, they're so pretty.
they're so much fun. Looking at the two graphs,
It's not gonna be fun.
okay, I'm gonna give you about 10 seconds to look at them and try to discern what's going on here, because then I'm gonna ask you similarities and differences.
Does everybody have Ashley's graphs kind of, so you can see this one?
Yeah, can you fold that paper back?
Yeah. I need that.
I was thinking your papers.
Oh.
There you go.
That'll work.
We're not talking, we're thinking right now. We're not talking, we're thinking. You're gonna get to talk in a minute. Actually, in 2 seconds. Okay, so they have similarities and differences. So I want you to talk with your table mates about the similarities and differences and possible causes. Well, you're going to explain it in a minute, so you can sit down and then get back up.
No, I know why our graph is the way it is. You know what I was also thinking, is that because the curve was right,
Well, okay, are you talking about how we wrote one
between that.
without 10 seconds? Oh, okay. So the variables
You had to touch your, you had to touch your card.
your variables, like I tried to use my driver's paper, so where it looks like
Well, that's what I meant, but I used it. What is it called?
So I would say your X, I would say you're like your X axis. You're not talking about the interval, the difference between.
That's the times that were measured.
I would say that, yeah, I'd say like X.
Right.
So there is a difference.
Right, and also with his distance intervals very.
No, it-
I went by every 3 and then you went by every.
Well, he first did 10 and then 20.
Yeah.
Oh, okay.
And then 30 and then 40. So his y axis is 10 and 30. Well, first it's 0 to 10.
Because I can't see the bottom of my glasses. So it's saying.
I only asked if you did every line.
I'm gonna avoid eye contact.
But if he skips a line, it would be
I didn't see it.
I thought he skipped a line.
What I'm wondering, do you know how? Because I couldn't see the dot.
You know what though, like if you just, because the top edge of their graph is what? I can't make the number out.
Like if you had technology.
How would they say?
I still think
So there's,
because if you look at the line,
She said she was gonna call on us.
so if you
versus 3.5 that's difference. So you're still going to have. Whereas let's say we starts kind of like falling off. So I think you want to use technology.
Compare the two, you would compare.
Just put 16 in my bag, because I don't want to.
Are we good? You want me?
Okay, 5, 4, 3, 2, 1. Good job, y'all. Okay, so we're looking at the similarities and differences in these. I don't know why I was gonna go over here and move this graph up. Maybe I'm senile.